we're going to go on to, we were talking about data capture, and we have all day, is utilizing drones for utilities. We've got a presentation from a team from Cognizant Drone Ventures.
Right.
And we've got Ken Kranz. He's the acting CIO of Cognizant Drone Ventures. And Carson Zerpa, he's associate director with Cognizant. And as I mentioned, Cognizant is a big data analytics firm. And I was really interested when I had heard about that they are branching out into drone ventures and the analytics for utilities. So Ken, I think you're here, but I think you said you have a video with Carson. But anyhow, look forward to your presentation.
So hello, everyone. Ken Kranz here. I'm with Cognizant Technology Solutions. Cognizant is a Fortune 200 multinational consulting company. So we have a very large client base, and we provide all types of consulting services to our clients. Everything from, well, basically everything digital. So everything from database management to systems administration to new product development, internal product development for our clients. We're very client focused. We put a lot of effort into making sure our clients are successful and that we focus on their data and their security concerns. I head up the drone venture for Cognizant. The drone venture was started back in 2014. As you can see, I'm also a certified pilot, as well as being a drone operator with licenses here in the United States and in Europe. And separately, under the guise of Cognizant, I do a significant amount of work for the FAA. We do a lot of work when it comes to drone safety and the FAA, NTSB, and NASA. And separately, we've made a lot of significant work results when it comes to being able to report drone issues and drone safety. So that's kind of my background. And now I'd like to let Carson introduce himself.
Good afternoon, everybody. So I'm Carson Zerpa. I'm an engineer. I started my career, a little more than 17 years ago, but I have 17 years focused specifically in the grid and analytics space for utilities specifically. And so, certainly covering, the operating technologies that you see here, but as of late, marrying those technologies with various applications like, image inspection tools like drones and system modeling tools like digital twins, we've seen a shift in the market to uptake in leveraging these technologies and driving business value. So go ahead and take me to the next slide, Ken.
Sure.
And what we're going to talk a little bit about today, obviously, is the digital twin as it relates to the electric utility space, how drones are contributing to that, and certainly, just to align with some of the things you saw in the previous discussions, obviously, leveraging those things, leveraging automated vehicle, both rovers and drones to capture specific images, driving and supporting those digital twins. And then we're going to, obviously talk a little bit about some of the data sets that we're capturing with the drone technology. And then just to kind of tie everything together, we'll talk a little bit about kind of our experience in terms of building digital twins and leveraging that, those types of data sets. Next slide. Digital twin, obviously, whether we're talking about a structure in the field from like a transmission tower, or we're talking about a boiler inside of a steam plant for generation, there's a physical asset that we're, for all intents and purposes, trying to model. And obviously, my background as a field engineer in power distribution space, started at a South Florida utility, several years back. One of the key things that I think we all recognize is that back in the day, and I'm going to say 20 years ago or so, my principal engineer was adamant that unless you physically designed it and the operations that have taken place on that specific device, you got to go out to the field and boots on grounds, figure the system out, troubleshoot in the field, and engineer and design and make decisions based on, physically visiting those particular assets. And I did that for a few years, and then one day it dawned on me that my principal engineer didn't go to the field as much as I did. And so I asked him, and his response was, "Well, I've designed all this stuff. I know it. I've pulled the orders, and that's why I'm doing it." And everybody has a Bob at their utility who can tell you all the specific details associated to a device. And for all intents and purposes, with the changing in the industry, we're losing a lot of those guys who are 40+ year veterans in the field from an engineering perspective. And what's allowed us to continue to accelerate as utilities is by donning, higher and higher levels of automation and analytics, basically maturing our digital twin from an asset perspective, and in some cases holistically across T&D, transmission and distribution for that matter. And so from a contribution perspective, what we have is, and kind of if we step back and we say, what is the path for us to kind of take on one of these initiatives, and what are the components, right? So what we have here is kind of a simplified view of what we look at when we start to address what we might want to do for our client in terms of digital twin. And so the collection piece of it, data in the last 5 years, in the last 15 years in the utility space is from a resolutions perspective, from an inputs perspective, has changed immensely, right? And so whether we're getting DMP3 data from a regulator or a recloser that's in on the medium voltage, or we're getting sub-second data at a relay at the substation, or 15-minute or 5-minute data from commercial clients from AMI, all those different inputs from a time series perspective obviously drive what we're going to be looking at, right? And then we have to align that with the assets themselves, like the asset performance management tools, maybe simplified smaller versions of digital twins, or even in some cases work order management tools, just to understand the last state or operation of a particular device. And so all that stuff kind of gets packaged into a set of data, contextual data that basically gets mined or gets processed by that virtual model. And so when I look at things from a digital twin perspective, you kind of have these three buckets, right? You have the platform and the infrastructure to support that. You have the simulation engine, and then you certainly have all the analytics behind that that drive kind of the analysis, right? And so fundamentally, in order to do that, from all these inputs, there's kind of that you have to kind of take those different data elements, and you've got to put it in a position that the tool has the capabilities of driving value on. So in some cases, like we just talked about, different levels of resolution and data from seconds to minutes. There might be some interpolation that needs to be applied there. Or there's data quality challenges, like you might need to have some tools for model validation, risk modeling that's managing basically from a data set perspective, a process data perspective, images that are captured by drones in the field, so that you can highlight higher levels of risk associated to certain line segments that might drive decision making for load balancing or switching and things of that nature under various conditions. And so from that processing in that model environment, obviously the outputs which are driving the business value for us as engineers, as dispatchers, as folks who are stakeholders in terms of the performance of these particular assets, there's the various areas of focus, right? So you have the people who are more, just wanting to understand, hey, are these particular assets running? What are their commercial impacts associated to these? What is it like, how am I going to manage the system as a whole, or the particular asset that's being monitored as a whole? There might be dispatchers who have focused views into digital twin, maybe a specific asset that they're laser focused on, or they may be looking at a substation or a switching station holistically. And then certainly, the data scientists, right? So these models that trigger, I think in the last call, we talked about highlighting change, right? A lot of these tools that highlight the change in the system are driven by mining that historical data, looking at the trends under various external parameters, as well as system like sensors and telemetry that's saying, hey, the change of X device under these environmental factors are causing X types of challenges, right? And so I think that if these data scientists continue to evolve and improve these algorithms, we're going to continue to see greater and greater capabilities with these digital twins. And we're going to talk a little bit more about some of the success we've seen here shortly. Next slide. So this is a little bit about the process. You know, when we work with clients, you know, or we coach clients on what to do for DT or digital twin processes, you know, a lot of people want to boil the ocean and they want to do everything all at once. But I think it's good to kind of outline what the vision is or the use cases that you kind of want to focus on, and then basically stack rank those use cases based on what is, you know, based on the sensing that you have in the field, the model data, whether it's your scanning facilities or you have three-dimensional CAD files from third-party vendors who are the manufacturers of those facilities, or it's a GIS model, right? Representation of the facilities, right? However, you know, based on the data you have, we can prioritize what is the kind of the quickest wins for you as a utility to gain value in terms of driving one of these particular processes. And then starting simple with a pilot is usually best, because then we can, you know, continue to tune the model, right? And so the nice thing about digital twin is in many cases it's an integration exercise to the telemetry that you have in SCADA or in your ADMS or EMS for that matter, or just the sensor data associated to your plants, right? Temperature probes, things of that nature. And so it's a lot of integration, but we can simply map those tools into to kind of lightly test and validate the use cases without having a major impact on the normal daily operations. And so once that's done, and we kind of, you know, tune the model and we verify that we're getting the results that we're looking for, then we look to how we scale that across the organization. So, you know, are we going to take this to the cloud? What type of resources do we need? Is, you know, kind of answer those questions in terms of what makes the most sense for the organization. And from there, we go ahead and map, you know, that path to scale across the organization and track the business outcomes. And so, you know, for all intents and purposes, you can kind of see below here is kind of how you can, how that all kind of, you know, flows kind of up and down across that process. And so mapping the use cases, generate the simulation models from the field data, you know, running it through data validation, data acquisition, running it through various analytics, and then mapping those business outcomes based on the operations that you see in terms of the dashboards, displays associated to the digital twin. Okay, next slide. So this is like the holistic view. So we recently have been working with a large IOU who's actually, we're basically trying to represent what it would take to model the dynamic changes for renewables and basically the dynamic cost of service and the dynamic you know, costing elements associated to managing renewables at different times throughout the day. And so, you know, obviously this is like the massive trying to digitize and do a digital twin of the grid itself, T&D, including substations. And obviously there's a lot of integration points associated to that to drive those applications. But the key being is this is just an example. You know, you can certainly start with a single substation transformer for that matter. It doesn't have to be the whole substation. Maybe you just start with a single substation transformer. You leverage the telemetry that you have. You use maybe some of the cameras in the facility to monitor temperature via infrared and the loading on it, and you can kind of, you know, walk your way out kind of modularly, piece by piece within that substation to have better visibility of it at a whole at a later date. So, you know, where a lot of people will take you straight to the massive solution and have a good plan for it, you know, don't think you have to do this right out the gate. You can start just incrementally and kind of work your way or define a path to get to where you want to go from a visibility perspective. Okay, next slide. So from a data governance perspective, we kind of have, you know, I like to talk about 3 different buckets when we talk about digital twins. Obviously, the you know, data is key, right? You know, good data in, good results, bad data in, bad results, right? And that's not a new saying. Everybody, it's been around forever. Still fundamentally the truth. The advantage of today, we have a lot more power and analytics and processing capabilities to help improve that data. And so when I look at kind of these three big buckets, it's, that master data management component really comes down to when we start talking about defining what the solution is, we start to look and say that for all intents and purposes, for all intents and purposes, it's the standards that you use to define. So when we look at a digital twin, we look at the assets that we're going to, basically import data for. What data do we need for what reason? When we go to model it, we have to define all those rules, in the front, and then set the controls in place to support that. The data quality obviously comes into the resolution of that data, the errors associated to it. For instance, connectivity modeling is quite challenging. Phase detection is quite challenging. Things of that nature. And so you having the processes in place to basically qualify the accuracy of the data when we're loading it, or highlight it for validation, or for in some cases editing, right? And this is quite similar to what we do in metering processes. Like, for instance, validation, estimating, and editing is a technique that's been used in the industry for decades at this point. And so that's kind of where you see that data virtualization concept, is where you might take this data, you're going to process this data to leverage it for your system model, and then you can reduce the overhead of all that data storage because you're using the key data elements that you need, as well as you're giving some, there's some analysis that's taking place in the inputs to make sure that, before you load a sample or piece of data in that might be suspect, it's either, it's being audited for all intents and purposes. If it doesn't necessarily comply with what's expected, it might go through a validation exercise, or even in some cases, it might be dropped and interpolated between, different time series data elements, right? And so all that helps drive accurate decisions and is required to be considered in the concept of building a digital twin, right? Next slide. So here's a couple other tools that we've deployed for model validation. So certainly a lot of the stuff we do is similar to what was seen before in the T&D side. So connectivity tracing is paramount, parent to child relationships, associated assets. Phase detection, as I mentioned, we're doing a lot with DERMS recently, and distributed energy resources, and so certainly the how devices are connected from a phase perspective is quite important. And so we're leveraging analytics in conjunction with the models to highlight changes between the performance of voltage to basically look and say, hey, this particular asset's actually on a B phase, not A phase, and vice versa. And so when it comes to that, we've seen when we make a recommendation to realign a phase code, we have 90+% there, but even quite better than that as the results of our tools to support with accelerating the deployment of digital twins in that space. And certainly there's some transformer mapping components that we've done similar techniques, but fundamentally and kind of tied to what we're trying to do today, and it's been a big push for model validation and asset identification is drone technology and rover technology, and just image inspection technology, image analytics, and AI. And so we've seen a lot of success recently in patrolling distribution, transmission, and even substation facilities to catalog different types of assets, mark different challenges that might be baked into our risk models for the digital twin. And, for all intents and purposes, it helps us, improve and validate the system model, and even on conductor sizes and things of that nature. So very, very useful tool, for leveraging, automated, vehicles to patrol and monitor facilities, and then correct the system model for all intents and purposes. And with that, I'm going to go ahead and hand it on to Ken to cover the drone technology.
Hey, thanks, Carson. And if I can ask, how are we doing on time?
Okay. Hey, Ken, you're good. You got to go ahead, go 15, 20 minutes. 15, no problem.
20. Okay. I ask because I probably have more image to show than we have time. So
okay, and that's okay, because we're going to segue right into the roundtable. So if there's questions, we can go into that.
Yeah, I'll try to move it along though. So like I said, we're Cognizant. We are a consulting company. We try to bring services, and when it comes to the drone, and actually it's aerial data, just imaging data in general, we try to take everything off of the client's plate. We become the one throat to choke. So this is what a typical path looks like. If you want to go into drone, have drone services done, we will typically help out with the discovery phase, which is really important because a lot of people and the drones to a certain extent are a shiny new toy, and a lot of people want to play with them. But sometimes, matter of fact, a lot of times the use case doesn't make sense. So we kind of insist on doing this discovery phase. We try to suss out, which use cases really are drones are a good fit versus body worn cameras or old fashioned manned aircraft or satellites, etc. But then we take care of the whole mission ops, and if they want a turnkey solution, that we'll do everything for them. We do software development. But the biggest thing, being an integrator, is the drone data management. We really focus on bringing drone data in-house and making it a first-class citizen in your environment. I will point out that we do a lot of work. We have built quite a large partner ecosystem. So a lot of the stuff you see here, we don't necessarily do all of it, right? We will pull drone data vendors in if we have to. We will pull manned aircraft vendors in if we have to. Same thing with the AI and analytics. We do a lot of AI and analytics. There's a lot of companies out there that also do it, and a lot of them have their own special secret sauce. Being a contractor, right, a consultant, we're not married to, we have to build a solution. We're not a product development company. We are really here to bring in the best of the breed and get the job done for our customers. The types of data that we'll bring in is anything from 2D images, videos, LiDAR, thermal. It really doesn't matter to us. On the bottom is just some of the companies that we work for, but you'll see it's not just energy. Well, and when you say energy, it could be electric, it could be oil and gas. We do a lot with insurance companies. We've even done work with crop, companies and mining companies. Our main focus is bringing, the drone solution to our client base. So, how does this all work? At a high level, right, on the left side, you could see the types of data that we bring in. Really, it's imaging. That's all we really care about. We joke around that if we can strap a camera to the back of a pigeon and have them fly around and collect the data, that would be fine by us, right? But we do quite a bit with the drone data. We do quite a bit with the manned aviation data. When it comes to terrestrial data, we're probably doing more with AR and VR nowadays, but we do use that to collect some data. So there is the whole collection for training, and then there's the collection for looking for answers. But the data comes in and it follows the same big data solution that we would take for any other data. The imaging data is nothing special, and we pull it in, we store it in our big data solutions, or if the client has their own preferred, we use theirs. But all the same happens. The same security is applied to it. Access is supplied. This way, if your data is in there and it should come down to even legal proceedings at some point, you can say, when did the data arrive? Who saw the data in between? How was the data modified? So that whole chain of evidence we also take into account. But the more important thing is running the analytics. Again, whether it's our analytics or third-party analytics, doesn't matter. We ensure that analytics gets run. We have the human in the middle to ensure, like the previous speaker said, that the AI is not 100%. It never will be 100%. There's always going to be a human in the middle at some point. And, the goal here is not so much getting 100% result. The goal here is to have as few, false positives and false negatives as possible and build up this training set. And while we're all starting now, we're all thinking of what missions can we run today and what can we find today. The really exciting part is where are we going to be in 5 years and in 10 years with the kind of analytics that we're going to be able to run. And by using solutions like this, where you store the data for a long-term process, you'll be able to down the road, do things like, I want to do change detection of this particular component over the last 5 years or 10 years or over decades. That's really where the industry is going. Some of the more popular use cases that we run into in the energy sectors, is shown here. And the way to read this is it's your typical magic quadrant, if you will. The line on the bottom is mission effort, meaning, and this one tends to be very drone specific. So the further you move to the right, the harder it is to execute that mission. And when I say execute it, it could be anything from the capabilities of the drone, the current regulations that are out there, the number of people that you would need to execute that mission, the weather, lighting conditions, etc. And the vertical is, just the development. What does it take to get this done? How much software has to be written, right? So there's some really nice low-hanging fruit that's out there in the lower left-hand corner with, the whole asset inspection, ice detection. We've done that for one of our power generation companies, where they have ice buildup in the wintertime on the inputs to the hydroelectric dams, solar panel detection, scanning solar panels, looking for effectively hot spots, but more than that to, figure out, is it a panel? Is it a string? Is it a cell? What's wrong? And what's likely to be causing it? When you start to move up in the chart, things can, in the vertical side can get a little bit more difficult, like fire risk. For fire risk, it's not just drones, right? At that point, we're taking in other variables, weather conditions, historic conditions, and trying to come up with an answer. And then if you move to the right, when you look at things like, right of way, that's, and wind turbine inspection, these are harder missions to execute. They're not at all impossible to execute. And I will point out, this happens to be a kind of a US centric map. We do this all over the world, right? So this layout would change depending upon where you are. And a lot of it has to do not so much with the development effort, but the regulations, how hard is it to do a mission? So here's just some snapshot outputs from, missions that we've done for clients, for the client data that we can share. And I'm just going to take a little side step to just point this out. We do a lot of work. We do a lot of work for different clients. Anything you see in here, some of the data you see in here will be from partners, like I pointed out, if I remember, but some of it will come from clients. Anything you see from a client has been approved. We are very, very picky about that here at Cognizant. We can't share any information with a client without their permission. So this happens to be client data, and it's been approved. But what you're looking at the left, that's your typical, vegetation encroachment type of scan. And, you can see right away that this was done by a drone just by looking at where the LiDAR is, right? You see, it's a very linear path, as opposed to if we had used a helicopter or a fixed wing aircraft, you'd have to tend to have LiDAR all over the place, right? In the middle is your typical asset inspection. So, it boils down to three things. One is classification. You got to be able to find a transformer versus a cross arm, to begin with. Then there's enumeration. How many of what did you see? And then finally, there's the defect detection. So they're all kind of independent of one another to a certain extent, but you have to go in that order. You have to find it first before you can count it, and you have to find it first before you can find it and compare it to other known good and bad instances to say whether or not you have a defect. And of course, with that goes the whole the risk management, which is the back end reporting that Cognizant brings to the table. So it's one thing to say this insulator is bad here and that insulator is bad there, but then you have to pull all this information together and generate a report. And not only that, but we like to joke that it's not done until that part is on the back of a truck and it's being sent out in the field to be repaired. And that's not as easy as it sounds, right? Because you just don't put it on the back of a truck. You have to say, well, what's the severity of the damage that we've seen? Is this something like stop everything, go out and fix this? Or is this something that could be, fixed in time? And if that's the case, there's certain different types of teams that go out in the field to do different work. It's got to go to the right team, and you got to kind of look at what their plan is right now. Where will they be to fix things? So you have to actually get it on the truck with the right team on the right time when they're going out there to do work anyway. Again, unless it's critical.
Hey, Ken, you got about 5 minutes.
I got 5 minutes. Okay. So
right on.
Here's the eye candy, man. So throw this stuff out here. So the drone group is actually part of the IoT group. So if you're looking like, let's say the lower right-hand corner, what you're looking at here, this was taken with just by a 2D camera, not a drone camera, but it shows, somebody going through a gate and the gate's wired, and we're actually able to sense using video how many people walk through the gate and tie that into how many people put a code in, right? So that's one example. The one above it, that's an example of this is actually a drone that's hovering. And what we're simulating here is that, somebody's walking into an area where there's blasting that's going to get done for a mining operation. So we're actually able to fly drones. They pretty much hover. So they're basically cameras. You just throw up in the air and say, hey, nobody's supposed to be in this area. Let me know if we have a fault. And the one on the lower left, that's just kind of show you can actually see the shadow of the drone in the picture there. And it just shows you some of the AI, the resulting analytics of the things that we can find. Again, this is all what you're looking at is the output of analytics. In this case, on the left, we're seeing rust. On the right, we're seeing things like chipped, missing, flashed over, insulators. There's two separate things. One is how do you collect it with a drone, and the other is what is the analytics, and they go hand in hand, right? What you're looking at here, this is not an energy. This is one of our telco use cases. But what they're doing here is this is a video. Typically, what we are capturing here is 2D pictures, very high resolution pictures. But this is how we go about making the digital twin. So a drone would fly around. In this case, this happens to be a fairly high level scan. The drone flies around. It's called a point of interest scan. It flies around and collects, hundreds of pictures that gets that eventually gets stitched together. After it would have done this one path, the drone would have dropped down a little lower. The angle of the camera would have changed. It would have gone around again and again until the whole thing is captured. And that's like the data input side. And that's especially when you want to do either training for, picking up components that you can do your AI training, your ML training, or for making the digital twin. So you have a nice, these all get stitched together in effectively one picture that you could rotate around when it's done. And that's kind of what those scans look like. Here's some resultant data. Some of this on the upper left-hand side is from some of our partners. It shows you the upper left one shows you 2D images and LiDAR if you look closely enough. And on the other side is the thermal data. We work with any data. Same thing in the middle. On the right, you're looking at just a snapshot of the results of doing solar panels, looking for broken panels, or at least panels that are not operating effectively. Lower left-hand corner is gas detection. So put a gas micrometer on a drone to fly it around. The gray area is actually the width of the drone flight. So you see the drone kind of flies around and mows the lawn, if you will. We figure out where the particles are, and we actually extrapolate that and find where the gas leak is. And it's similar but different when it comes to the thermal, right? We actually can find hot spots and flag those hot spots accordingly. Here you're looking at just some post-storm damage analytics. This is actually client data that we were able to share. And so, we teach poles what they look like when they're vertical. We teach what it looks like when they're not so vertical, right, at different steps. But this shows you the actual AI, what it can do, right? It can actually, it's not just like I've taught it what a pole looks like vertical and I taught it what it looks like on the ground. It can interpolate and say, no, I've done this training and I understand we have poles that are laying down over here, right? So, so we can kind of get that information. And the report that you see on the right is just one of the reports that we generate that shows where damage has taken place. So, I kind of rushed through that. I know we have one more section. I don't know if we have time for this. If so, I'll turn it over to Carson, or we can go straight into the roundtable if you want.
Yeah. So Ken, I think what we're going to do is we've got Sky Perry's presentation before the roundtable, and if there's a spot in the roundtable, I want you to go back to this section. So yeah, thanks for the eye candy stuff. I really wanted to hear about how the rubber hits the road, or wait a minute, the propellers hit the air, or stuff like that.